If you know the best way to get home, but your spouse insists that they know better, which way do you choose? Is it a trick question? Maybe. It's time for TechWiseTV. Some of my favorite phone applications are the mapping programs, because we get very updated maps along with real-time traffic conditions. In fact, it's become so helpful that I often put in my destination even though I know exactly how to get somewhere, because it works brilliantly. Now, my wife thought I was nuts for following these directions one day because we were only 2 miles from home, and the phone was telling me to cut through an adjacent neighborhood, which was full of stop signs and slower speeds. We would never normally take that route, right? Well, I bowed to the pressure, and as she convinced me, I stayed on the route we normally take, and then we promptly sat in traffic for 20 minutes. There was an accident that we didn't know about. Turns out the phone had better information than we did. Well, this is one way in which I like to understand some of the benefits of a software-defined network. The idea of a smarter controller that can combine the big picture of all that is currently happening within a network and apply that to the wishes of a given source or application to dynamically choose the best path to achieve it, which is relatively simple in theory, but a little bit more difficult to pull off within a data center network until now. Because today's topic is segment routing. It's a label switching architecture where packets can be directed through a specific path other than that normal shortest path first that you'd normally take. And it's pretty straightforward. Application specifies what they need. That then gets combined with the topology, link state, or link utilization information. And then applications are mapped to a path as defined by a simple ordered list of segments. Well, we're going to show you exactly how this could be working in your data center using the same Nexus switches you may already be using. And Vipul Shah joins me in the lab next. Well, Vipul, welcome to TechWiseTV.
Thank you for having me here.
Glad to have you because we get to figure out exactly how segment routing now applies to the data center, as you're telling me.
That's correct.
Because we've covered it here before, but that was more service provider. But the same principles are in effect, but there's probably some unique distinctions for the data center that are going to scratch some itches, so to speak, for some of our data center operators. Fair enough?
Fair enough. So
how does that work?
Let me explain. So segment routing for data center uses the same construct and concepts as what you mentioned, application engineered routing for the WAN side of it. But what is different in the data centers today is that the applications today are growing very rapidly. And that puts a lot of demand on the network of the data center to become more agile and become more adaptive.
Right.
This is where segment routing comes in. Because now you're providing the ability to control your application and the speed and delivery of your application from end to end with segment routing for the data center.
And so you're saying that the network has the ability to take instruction from the application. And so instead of the network saying, this is how you get from here to here, that's the way we've always done it, that's the way we're going to keep doing it, you're saying now it can listen to what the application needs and then have some way of understanding it and then translating that into an explicit path? Is that the right way to put it?
That's exactly true.
Okay.
So let me explain
that
to you
sounds desirable.
So what you're doing is, let's look at the example of a data center today.
Okay.
So what you have is your compute here, your core, and your leaf and spine. This is a
class
typical network class architecture that you have today.
Okay.
What is happening is, with the compute, you are saying that I have a certain application that I'm running on this. But I want that explicit control so that I don't slow down the speed or the delivery of my application.
You know exactly which route you want it to take. Okay.
Exactly. So that means now I want to take my application and I want to send it through a specific path. Now I have the ability with segment routing to do that. Now I want certain traffic and certain applications to take a certain path, and that's where segment routing for data center comes in.
Are data center operators trying to do this on their own manually and it's kind of painful right now? How is that being done?
So what is happening is that today with data centers, you are putting a manual control on those forwarding paths, right? Either the application will take the shortest path, or either the application will take the path which has been defined by the network's construct.
It's like VRF segmentation or something, this type of stuff, where they're manually saying this is where I want you to go based on virtual route forwarding?
That's right. So most of the...
That's painful.
That's a pain for the network operators today. So we want to provide the operators today the ability to define the path for the networks, right?
Okay, I'm listening.
And what is happening today is that most customers are bringing that WRF type segmentation down to the top of the rack, down to the applications.
But we can get away from that.
We can get away from that.
Let's see how. Okay.
But what really is you're not trying to get away from that segmentation. You still want to provide the segmentation, but you want to provide the agility for that segmentation.
So it needs to be flexible based on what you're saying the application
Exactly.
needs. Okay.
So you're making the networks more adaptive to your application. Let me show you an example of how that is done. Let's consider this network, right? You have your production traffic going through a certain spine, and let's say you have your backup traffic going through.
Or we want it to do that, right?
Right.
Okay.
And then your backup traffic going through a different spine. Now what is happening is, in your fabric, everything is connected to each other.
Right.
So now, if you did not have a type of agility to separate that production from backup, then everything would be going over the entire network. So you don't have control. What this is doing is it's giving you the control, saying, hey, what I want to do is I want to assign specific leaves to take that specific production traffic, right? I don't want to mix my backup and production traffic. So now all my production traffic go through orange leaves, right? And all my backup traffic go through the blue leaves.
Okay.
This is where the networks become adaptive. Today, in the night, my application traffic doesn't have much usage, right? So I'm not using the bandwidth for my applications.
So let's share it with
So
the
let's share.
backup?
So no, not share it with backup. How about giving that bandwidth to the backup to complete faster in the night? So that means I can take these particular leaf and say, hey, I want to turn that into my backup leaf, right?
Okay, cool.
So now I'm creating more bandwidth for the backups in the night, so the backup can complete faster.
And so we're giving these instructions to the backup applications or the production applications to be able to ask for that themselves, as opposed to some manual time of day routing, you know, throughout every point in the network.
Yeah, so what we are doing is you're just making the network adaptive to those needs.
I agree it's desirable,
Yeah.
but now it's got to be simpler than what we're doing already. Thus,
Exactly.
Okay, so how does that work?
So let me take you to exactly what segment routing does.
Okay.
So let me give you the basic form of segment routing. Today, with all other network solutions, we have a data plane and a control plane.
Okay.
Segment routing doesn't go far from that. We still have a data plane because we have forwarding paths,
Right.
and we still have a control plane because you want to control that network, right?
Okay.
Nexus 9000 and the Nexus 3000 is where we are delivering segment routing today.
Oh, so if you already have those products, then this is something you'd literally just turn on.
That's right.
So it's nice. And we're the only ones doing that.
That's,
Or we're the only ones doing it in Nexus, because that's...
No, we are the only ones doing that for data centers today.
Okay.
As we mentioned, we are already doing it for the application engineered routing for the WAN side, but for the data center side, this
That's
is the
new.
first. Right.
Got it.
So,
Congratulations.
so thank you very
All
much.
right.
So what we've done is for the network constructs, we have created a data plane using the MPLS label stacking today.
Okay.
So we are not going far from what MPLS was,
Okay, good.
right? But we are giving that agility and ability with
So label switching is still there.
Label switching
Okay.
is still there.
MPLS is still kind of in the background.
But what we are doing different is today, MPLS label switching uses traditional forms of discovery, which is using LDP and RSVP.
Ugh.
It doesn't scale for data centers.
Yeah, and they don't communicate with each other, do they?
And they
So
don't
you-
communicate very well with
you
each
get
other. So there's
synchronization
complexities,
issues.
there's
Yeah.
performance issues, which, for data centers, you want that scale and the ability
Right.
to use standardized networks.
Okay.
So what we're doing is, for the control plane, we're using BGP.
Okay.
BGP label unicast is our control plane. And there's very specific construct for segment routing, which many of our audience may know,
Okay.
is that with segment routing, you have three kind of labels, right? One is prefix, so
Okay.
that means you assign that segment in segment ID, right? What does that really mean, that segment in segment ID? One is prefix, so that means I can assign a label or a specific ID to a specific prefix that's coming into my network.
And it's going to be a device or a location?
That's
if
a
that
route,
goes? Okay, a route.
a location,
Okay.
right? And the other thing is the label to every node and every adjacency is what we call as nodal SID and adjacency SID.
So modal SID and adjacency SID. Okay.
I
So with
would
those
say
three
the
things, they
constructs
work
for
together to then list out, here's the list of instructions to be able to do that explicit path?
Yes. So
Okay.
what we are doing is segment routing is source-based routing, right? That's
Okay.
how you get control of the network. In this particular example, if you look at it, the application desires an optimal path through your network. When the data comes in, we are saying that particular path for that application doesn't necessarily have to take the shortest path, because that's not the most optimal path. My shortest path would be through switch 65
Right.
and down to Z. So from A
Okay.
to Z, I'm going through 65.
But it may not be the best path.
But it's not the best path, because let's say this particular adjacency is heavily utilized.
So the application knows what it wants. How does it then communicate? It uses some combination of these IDs?
Right. So what we are doing is we're taking those labels,
Okay.
right? We're taking label 65, we're taking label 66, and we're saying that let's use a particular adjacency, not 9002, let's use 9001. So we infuse these labels into the data packet header, right?
And 9001 is an adjacency.
9001 is this adjacency between 65 and
Defines
66.
that path, essentially. That's interesting, because we don't usually define paths. We usually define just a router address or something.
Correct.
Okay, interesting. Okay.
Right. So now what we are saying is, let's infuse 66, 9001, and 65 into the packet header that provides now the application to say that, hey, I've got the most optimal path,
Right.
and this is my optimal path through
Interesting.
A to Z.
And as it starts as an ordered list of segments, and as I understand it, it's a specific order. It literally is simple as almost this text-based list. So as it goes through here, you're popping off the one it just used because it's
Right.
not needed anymore. And you can still load balance with that type of instruction set as well. It doesn't have to be always this route. There's room to leave that flexibility still in there too, as I
That's where
understand
you're
it.
providing the
Okay.
flexibility for the network, right?
Very, very interesting.
So
okay.
this gives you that explicit path control. But there's also a way you can say, I can still take the shortest path. So let me give you an example for that. Now I have a particular prefix that's coming in, right? So node Z is going to advertise that prefix with a specific segment
SID1.
ID, SID1.
Okay.
Right? So SID1 is propagated through my entire network, where everybody comes to know that the
Yeah.
entire network uses SID1 for prefix
if you see
1110.
SID1 anywhere on here, send that way.
Send it that way.
Okay.
So that means now I'm going to send it through the shortest path. Segment routing gives you the ability
You can
to
still fall
forward.
back to methods that are necessary, because perhaps almost like a default route, then the application doesn't have to be explicit. So if it's not doing that, or
Correct.
it's not set up for that, then you still are going to, it's not like you're dead in the water and it goes,
Right.
you didn't tell me where to go, so I'm just going to sit here.
Correct.
No, it'll follow that. Okay,
Right.
got it.
So that's what explicit path forwarding, shortest path forwarding. That's why segment routing comes in with the ability to provide labels for every.
Interesting. And I love the
Perfect.
fact that it's very human readable as well. Simpler even than IP addressing schemes, because you're not dealing with subnets and different things like this. You're
Right.
literally dealing with, hey, it's these numbers can make sense for a unique network.
Right.
Now, I would also assume then that this, for a data center, that same information in that ordered list could be handed off to the WAN. We mentioned SP supporting this as well. So application engineered routing, this is going to be something that forwards into that as well.
Right. So
Okay.
application engineer routing with segment routing for data center complement each other.
Beautiful.
Now you are giving an end-to-end control to the network operator to say, from my compute across the WAN to another data center, I have the ability to define the explicit paths for those.
And I know this answer from the other show that I had done, but because Clarence Fifi was on, and he's one of the writers of the working, doing the work.
architect.
He's the
Yep.
architect, and he
Yep.
had kind of created this idea because it's the complexity that it solves through its own simplicity, so to speak, is also, it's an open standard, right?
Right.
So this is not something that's Cisco only by any means.
This is led by Cisco.
But it's led
no,
by Cisco, and we
it-
certainly have the first one, as you mentioned, to have our products out supporting
Right.
it.
And I also want to mention, as an industry first, we are also doing ISSU on the Nexus 3000 and 9000. So segment routing with ISSU is another differentiator.
that's a nice uptime,
right,
yeah.
on the data center. And the other thing is that with NX API, REST automation and orchestration, you are enhancing the ability for now the data center operators to say, I can automate and orchestrate my network
Yeah, that's a
using
big
the
thing right
automation
now.
framework that we provide with the Nexus.
So all of this
pipeline.
information could be fed bidirectionally through these open APIs that we've got in the
Right.
Nexus platform.
Exactly.
Because that's been huge. So all your orchestration, your automation,
Yeah.
that's certainly not going to be hampered. This is going to play part and parcel with that.
And the network operators can use that NX API and the automation framework with the controller to learn the performance of your entire network and create that adaptable paths as you deem fit. Right?
Perfect. So Nexus 3000 and Nexus 9000, we can play with this today?
Yes, you can do that.
Perfect. Vibal, thank you so much.
Appreciate it.
Appreciate
Thank
you
for
walking me
having
through this. Hey guys, one of the biggest values you could get out of this particular show is the workshop. We do a workshop with just about every one of them. You can look below the video to find a link, hopefully to the live version where you get a chance to interact with some of the same experts that we use on the show and cover the topic in much, much more detail. It's incredible value, and in case you missed one, you can always go to the archive at TechWiseTV.com, look them up there, and you won't want to miss it. It's good stuff. Check out the workshops, TechWiseTV.com. See you there. You can see how we are leading simplification for the data center. The industry is already following this. This is software-defined networking, a level of intelligence bringing great power to adapt to the dynamics of any application. In fact, think about service-level agreements with dedicated forwarding and bandwidth for certain traffic types like video, trading, or content delivery traffic. In fact, if you're an e-commerce, retail, financial, a web or service provider, you need to try this out. And if you already have the Nexus 3000 or 9000 series, what are you waiting for? Hey, join us for the workshop. We're going to take your questions live as we go even deeper. But that's it for today. I'm going to put up all kinds of resources in the show notes at blog.techwisetv.com. You can also follow me on Twitter for updates and insights and all that good stuff. You should also follow the show, of course. But with all that, if you can only remember one thing, TechWiseTV.com. All the shows, including this one, can be found right there. So thank you so much for watching. We'll see you online.